Good morning, Year 10. I just wanted to record a video to supplement your understanding of the Hegde tasks that were set yesterday to do with parallel and perpendicular lines and how to manipulate equations when the lines that you would draw from those equations are meant to be parallel, and then also when they're meant to be perpendicular. So I'm going to illustrate how this works by coming up with a little question which I'm going to answer. I've just made this question up and it illustrates how this all works. So this is the question: show that the following three lines are parallel. Okay, so you'd imagine I'm going to draw three lines now on the page, but I'm not. I'm actually going to put three equations on the page, and we're not actually going to draw anything. So that there is an equation. It contains two variables, a y and an x, therefore you can plot it. When you plot it, what you are doing is you are showing all the values of x and y for which the equation works. For example, if I set x to 2, y would be 14. Therefore, the point 2, 14 would be plotted, etc, etc, etc. I can plot as many points as I like. If I plot them all, I get a straight line. Now, you can find the gradient of that line by drawing a triangle on the diagram and doing the height divided by the width, the triangle. We've done that lots and lots of times in numeracy as well. But you should already know what the answer to that would be just from looking at this here. It's there, it's staring you in the face. You should know it's 6. The gradient of this line is 6. It would be if you plotted it and then drew that triangle. I've talked about this many times, okay? But it's the number in front of the x, as long as it is written in this form, y equals 6x plus 2, okay? So we're going to show that that line is parallel to these other two lines, okay? And the other two lines are given by these equations. So there we are. I've got three different equations on the page. Each of them could be plotted and you would get three lines, and we're being asked to show that those three lines are parallel. How do we do that without actually plotting them? Well, it's very simple. We make sure that all three equations are in the form y equals mx plus c. Okay, in other words, they look like that. That is already in the form y equals mx plus c. Okay, you can see that they're similar. The m is the 6 and the c is the 2. And the m, as we've talked about before, is the gradient of the line if you were to plot it. So what I need to do is just to rearrange these to make y the subject. So if I start with this one here, I've got 2y minus 12x equals 1, so we'll start by saying that 2y is equal to 1 plus 12x. And now I will divide both sides by 2 to give me y equals a half plus 6x. Just going to switch around these two here and I'll get y equals 6x plus a half. Bang, done. I can now see that these two equations here, if you were to plot them, would lead to a pair of parallel lines because they both have this 6 here. Okay, you should probably already know what the 2.5 mean as well, but we're not worried about that at the moment. Okay, so what about the other one then? Y over x equals 6. Well, this one's really easy. If I multiply both sides by x, that turns into y equals 6x. Bang, done. Okay, I can now say, to finish my question off, something along the lines of all three lines have a gradient of 6 and so are parallel. I didn't plot anything. I didn't go anywhere near a bit of graph paper to do that. I can just see it from the fact that I've got these 6's here. If I were to plot them, quick sketch to show you what it would look like. I'd get 3 lines. They'd be very, very steep because 6 is quite a steep gradient. This one here would look something like that. This one here would look, oh god, it's going to be quite hard to show you, something like that. And this one here, the bottom would look something, I'm going to get this wrong now. It's not brilliant, like that. They don't look parallel. They don't look parallel. They're supposed to look parallel, okay? The point is that these points here are where they cross the axis, and they're given by these values here. So that's supposed to be 2, that's supposed to be a half, and that's supposed to be 0. Oh, I've made a right pig's ear of that, really, haven't I? But hopefully you get the idea, okay, that they are all parallel. But I didn't need to draw that. I could just see it from that. So anyway, a classic question that you might get asked, and I think this is what the Hegarty ones talk about, is could you come up with another line that is parallel to these 3 that passes through a particular point? Okay, so suppose I'm told that the line passes through, I'll just make one up, it passes through 3, 15. All right, so I've got a line and it passes through 3, 15, and I've got to find the equation of that line. Okay, so it's got to be parallel to these 3. Okay, so I'm trying to find a line that's parallel to these 3 and passes through 3, 15. Well, if it's parallel to these 3, I know that it's y equals 6x. What I don't know is what number to put on the end here. So I just put C for now, like so, because that's the general letter that we use for that part of the equation. And then all I need to do to finish this question off is to find the value of C. And to do that, it's really, really simple. I literally just sub these values in for x and y, remembering that this is the x and this is the y. So if I do that, I get 15 equals 6 times 3 plus c. So if I take, that's 15 equals 18 plus c. So if I take the 18 off both sides, I get minus 3 equals c. So I now know that c is actually minus 3 in this case. So my line is y equals 6x minus 3. And that line there would pass through the point 3, 15 and is parallel to the other 3 lines on the page. Okay, I can draw on my rubbish diagram, I can draw it. So minus 3 is kind of here. And if I was to draw another that's supposed to be parallel line like that, then that would pass through the point 3, 15 if you drew it properly. So that's it. That's how parallel lines work, and you can do all the work without plotting graphs, and it all works. So I'm going to flip the page and do some work on perpendicular lines. Okay, well, first of all, you need to know what that word means, perpendicular. Hopefully you do. Perpendicular just means at right angles. So if I just draw a line like that, and I want to find the line that's perpendicular to that, I just move my ruler around like that and draw a line down there like that. They are what we call perpendicular lines, and they have a right angle here. So with parallel lines, these numbers were the same. In the example I did, there were 6. For perpendicular lines, the gradients are not the same, obviously, otherwise they would be parallel, but there is a relationship between them. I've probably shown you this before, but I'll show you it again now on a piece of paper here. So on this piece of paper, I've got some axes drawn. There we are. I haven't put numbers on them, but let's suppose they go up in 1s, 1, 2, 3, 4, blah, 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 whatever. Okay, if I put a line somewhere on there, this line here, for example, let's be careful. There we go. That's pretty good, I think. Yep, I'm happy with that. there we are. There's a line on the diagram. If you want to find the gradient of that line, you would draw a triangle. I'll do it in red on the diagram. Any size, doesn't really matter. There's my triangle. And you would divide that number by that number. Check that it's positive, if it's positive or negative. This one's positive, and that would give you the gradient. So the gradient of this line is 4 divided by 2, which is 2. More than that, I can see that it crosses at 3. Therefore, this is actually the line y equals 3x. Oh dear. It was all going so well. Sorry guys, made a mistake. It's the line y equals, I have to wait for my Tipp-Ex to dry now, aren't I? While I'm waiting for my Tipp-Ex to dry, I will put +3 on the end, because it crosses at 3. And when that has dried, I will fill that in with a 2, because it has a gradient of 2. Okay, now, if I want a line that is perpendicular to that, remember my diagram here, I'll need to turn my rule around and get it on the correct angle, which is something like that. And we'll get this exactly right. It's not going to work very well. Let's do it there. There we go. Okay. So that. There we go. That line there is perpendicular to that line there. Now I wonder what its gradient is. So to find its gradient, I'm going to need to draw a right angle triangle on it again. Let's do it here. And I'm going to, this time it's 2 and 4 again, but they're the other way round. So to find the gradient, well, first of all, I can see it's negative because the line's going down. So it's negative, that divided by that, 2 over 4, which is -1/2. So this one has a gradient of -1/2. And this one here had a gradient of 2. I can also see that it crosses here at 1/2. Oh, I can put my 2 in now. There we go. So this line here has the equation y equals -1/2x, that's the gradient, and in this case it's +1/2. Okay, I'm not so worried about the +1/2 on the end. That just depended on where I drew it. Okay, if I drew it up here, it would still have a gradient of 1/2, but it would, -1/2, sorry, but it would cross at 2. Or here it would cross at 3, or 4, or 5. It doesn't really matter, the number on the end. What matters is that you understand that being perpendicular means that its gradient, if that one was 2, would be -1/2. So what's the relationship between these two values here? Well, it's very simple. This is the reciprocal of this. Okay, I think I've mentioned reciprocals before. So reciprocal is when you flip a fraction upside down. So 2 isn't a fraction, but if you think of it as 2 over 1, flip it upside down, it becomes 1/2. And then all you do is you put a minus sign on. One thing's guaranteed. If the gradient, if you want lines that are perpendicular to one another, one of them is going to be going uphill and one of them is going to be going downhill. Okay, otherwise they're not going to be perpendicular to one another. So you will always have different signs for the two lines, like so. Quick example then. So suppose I said to you, I've got the line y equals, let's have, so we'll do a hard one. What do you reckon? No, let's keep it simple. So y equals minus 1/4 x plus 5. And suppose I said to you, I want to find a line that is perpendicular to that and passes through, so it's got to be perpendicular and passes through, shall we say, I'm just making this up, can you tell? 2, 10. Okay, so I want a line that is perpendicular to that and passes through 2, 10. Okay, well, it's a very similar technique to what I did. Where's it gone? Here. And I had one that passes through 3, 15. And I started by writing y equals 6x plus c, because I wanted it to be parallel to the other 3 lines. Well, this time, I want a line that is perpendicular to this line. In other words, I'm not going to use this gradient. I'm going to use the gradient that a line that was perpendicular to this would have. And so, to do that, remember, I find the reciprocal of a quarter, which is to flip the fraction upside down, and then change the sign. So I know the line I'm looking for is the line y equals 4x plus something, and I don't know what the something is yet. To find the something, I look at the point that they've given me, and I put it into the equation. So I get 10, that's the y, remember, and that's the x, is equal to 4 times 2 plus c. So 10 is equal to 8 plus c, so c is equal to 2. Therefore, the line I was looking for is the line y equals 4x plus 2. That line is perpendicular to that line there when you plot them. I hope that helps with the Hegarty tasks. Feel free to contact me at any time if you need help with that. I will be moving on to some new work next week. I think I gave you a copy of the topic list a lesson or so ago, and that had those green, we got it here somewhere, if I can find it, I'll show you now before I stop talking. Oh, here it is. Okay, so these are our topics for this term. We're running through all of them. So, understanding gradients of parallel and perpendicular lines, that's the Hegarty numbers. That's what we're doing at the moment, today or yesterday if you've already done it. And next week we'll be moving on to looking at nth term rules, a completely different topic. Okay, remember all this stuff is maths stuff for higher tier. When we get back after the break, hopefully after June, I'm praying, we'll look at some papers, and you'll see a lot of these techniques coming up in there. Okay, I feel sharp now. Thank you for listening. Have a lovely weekend.